Hey everyone, I am Joe Blizzard. I am the STEM teacher here at Roper Mountain Science Center. Super excited that you're here with us today. We miss having you here in person, but at least we can kind of meet this way and show you some cool stuff like we would if you came here. So we'll start with that. Why not? All right, so I want to show you something cool. This is called a plasmosphere. You may have encountered one of these before. Some people have them at their house. Teachers have them sometimes. Science centers, science museums have them often. All right, but they're kind of cool. And you know that if you, let's change views really quick. Awesome. All right, so it's kind of this glowy thing. It's got a glass globe around it with some gas inside. And if you touch it, you get this kind of cool blue lasso of light happening. Sometimes this one's a little blue, a little purple. You can get a couple of those going on. You can add some other fingers and get all kinds of cool little beams of light happening inside of here. And if you take your whole hand on it, it starts to make a sound. You can hear this zzz sound. And you get this really strong lasso of light happening. And you can get like a light print of your hand over here. It's just really cool stuff. And that's kind of the basics of this. And I'm showing you this because my goal for the day is for you, through understanding some of the stuff we're going to talk about with energy, is next time you see one of these, to be the smartest person in the room. You'll be able to say, I know what's going on inside of there. And I also want to show you something kind of cool. This is a fluorescent light tube, and I do want to say this is a don't try this part at home situation, because if you break these, there's stuff in it you don't want to be breathing in. So I can show you with this one, and most plasmospheres aren't quite as powerful as this one, so this doesn't work with all of them. All right, so if you look, you can see that in a teeny tiny window high up in the corner there, you can look and see that I have this fluorescent tube in between the camera and the plasmosphere. But I'm not touching either one, and I'm just going to kind of hold it in the middle. And on the big view there, you can kind of see the light. But if I were to touch the plasmosphere, the light comes on. You can see that the end is dark, but the rest of it is lit up, especially more light towards my hand. I can also get it really close to the plasmosphere, and it will light up. I'm not touching the plasmosphere. And again, there's no cords here. It's just my hand touching it. And then if I touch the plasmosphere, it lights up really bright. You can see that lasso of light coming towards it. So that's really cool stuff, and there are reasons why this happens, and I'm going to hold off from telling you those reasons at the moment, because we want to set you up and understand some other aspects of energy so that you can really truly understand what's happening in there and be able to explain it to someone. All right, so we're going to start talking about energy in general. Energy is the ability to do work. And with work, we just mean to cause something to happen or to move something. So like when I move, I've used some energy to move myself. So I've done work. So anything like that, that's work, and that's what energy is. We're going to focus in on the law of conservation of energy. And the law of conservation of energy states that energy cannot be created or destroyed, but it can be changed, and we think about changing in terms of transfer, which is to move from one place to another, or to move from one object to another, and then transformation means to change forms. There's lots of different forms of energy, and we're changing forms. As far as energy being created or destroyed, it just means it has to come from somewhere and has to go somewhere. Like, we don't just make it out of nowhere, and we don't just throw it away. Like, it just changes and moves all over the universe. So that's that. So I want to show you an example of an application of this law of conservation of energy that is kind of cool. All right, so let me line all this up. All right, so we have what I call, it's called a high road, low road. So in the back, it's the high road. High road, they both start the same, by the way. And they both level out the same, but they change right about here. The high road stays high, and it just equals out. It flattens out and stays the same to the end. And then the low road has the first hill, then a second downward hill, flattens out, comes back up a hill, and then flattens out and equals out with the other one at the end. And we're going to raise two racquetballs. So we have racquetball, if we can change to this view, racquetball A, and we have racquetball B. Racquetball B will be in the back, racquetball A will be in the front. And we're going to race them and see who wins. Now we can change back to this view. All right, awesome. So, in your head, I want you to make a prediction. Who's going to win? Is it going to be B on the back track? And the back track is shorter, by the way. It's 25% shorter than the front track. So is the back track going to win with racquetball B? And then, or is the front track, longer track, 25% longer, is it going to win with racquetball A? So A or B, lock it in, and we'll test it. All right, so watch, and if they stay on the track, awesome. So if you looked, A won, but watch again, because I know it happens quickly. Make sure I'm not tricking you. All right. All right, A won again, and spoiler alert, I could do that all day, and as long as they stay on the track, the front one's going to win. I can switch racquetballs. It doesn't matter. The front one will always win. Which is weird because it's a longer track, right? And it has an uphill in it. So why does that happen? There's reasons. Again, I'm not going to tell you quite yet. I do want to establish a couple things. First thing is, this is mechanical energy. So mechanical energy, and we have a slide for that. Mechanical energy is the energy due to the motion and the motion and the position of an object. So the motion part, we call that kinetic movement energy, and then position, that's potential energy, that's the stored energy. You can talk about it in different ways. There's different forms of potential energy. All of the movement energy is kinetic, but the potential energy has to do with position, and it can be a rubber band. When you change its position to being stretched, it has stored energy. You let go, it's kinetic. But the one I want to talk about is due to gravity. Gravity compels us to the ground, and right now I'm holding one of the racquetballs, and it wants to be on the ground because of gravity, but I'm holding it. I'm keeping it away from the ground. If I were to let go, it transforms the energy into kinetic, and it will stop. If I stop it, and it did, it's not on the ground yet, still has potential, still can be transformed into kinetic, but the amount of drop it has that will release that much or transform that much potential into kinetic. So that's potential to kinetic. And that concept is why this works. So what's happening is the back track and the front track are the same when it comes to the amount of potential energy we start with. It has the same elevation off the table, so that's the amount of potential energy it has. When we let go, we transform this much into kinetic energy, and the back track uses all of that, only uses that kinetic energy to finish out the track until it goes into the bucket, and then it transforms the rest of the potential from being up here into kinetic as it falls. The front one, however, it gets a little more kinetic energy because it's got some other things happening. So in the front, we have the first hill, and it flattens out, the same here, and it changes here. It has the same slope. So that means we are doubling the amount of kinetic energy. So it's transforming more potential into kinetic until we have double the amount. And so it has twice as much kinetic, and it's going twice as fast. Because it's going twice as fast, it gains a little extra distance, and then it transforms the kinetic back into potential. So they have the same amount of kinetic here, but this one has gained a little boost of distance because it had a boost of speed from the extra energy. So I'm going to do it again. I will put B in front, A in back, so you know it's not the racquetball that matters. And if you just watch when it goes here, you're going to see it speed up. So I will let go, and right there at the hill, well, when it stays on the track, it's a lot better, but we'll do it one more time so you know I'm not tricking you. And, well, you get it. It's sped up here, and it works. I promise. All right, so, very cool. That was just mechanical energy, however. And we're going to give everything initials as we go to make our explanations a little bit different and to give you a visual to look at. So that's mechanical energy. Let's talk about some other forms of energy and then see how they relate to each other with the law of conservation of energy. Electrical energy is the energy flowing in a circuit. That's electrons moving in a circuit. If we move electrons, we have electrical energy if it's in a circuit. Thermal energy is the movement of particles in a substance. Faster is more thermal, slower is less thermal. And we sense that as heat. So that's TE. CE, that's chemical energy. That's the energy stored in the bonds of matter. We break the bonds, we transform the energy. All right? And then RE, the definition up there is a little tricky. We pulled that from the standards, but basically it's radiant energy is electromagnetic energy. And for 6th grade, we just kind of focus in on light here. So if we see light or we talk about radiant, we're just going to put those kind of interchangeably from this point on in the show today. All right, awesome? Cool. I think you are ready to apply this by thinking about systems. When I say system of energy, what I'm talking about is a small part of the journey. It says energy is constantly moving and changing through the universe. So we're just going to take a small bit of the journey of energy. We're going to use one of these. And we'll get the lights and switch camera views. Right now you can't really, it just looks like a white stick or something, clear stick. But if I'm here, you can see it's got a little bit of yellow going on. But it's hard to see, so let me change something so you can see it better. We mix some stuff up inside of here. And you can see, you're probably guessing that this is a glow stick, and you are right. All right, so this glow stick had something change inside of it. So it started with one form of energy and transformed it into another. If we could change views really quick. And we're going to talk about what happened. So we're going to do, I call this an energy transformation map. So what energy did we start with, and then what did it change into? So I want you to think in your mind. We have our 5 choices up here. What was the starting energy? Was it TE, EE, ME, CE, or RE? Thermal, electric, mechanical, chemical, or radiant? And I can't quite hear you from here, but I can hear your brains working, and I'm pretty sure you told me chemical energy. So chemical energy, there was energy stored in the bonds of the chemicals in here. There was dividers between them. I did use mechanical energy to break this, but that's not what caused the energy to change. It was the mixing of it. We just broke the dividers. So think in your mind. What did it become once we broke chemical bonds? What energy did it transform into? You can kind of see this if I move it around. It's kind of cool. All right? Yes, it is radiant energy. Perfect. So we have light happening, radiant energy. Now some people think maybe there's thermal involved here, because a lot of times when we have a chemical reaction and we have light, there's heat too. There's no heat involved in this one. This is just a luminescent reaction, which means produces light. All right? So good job. I think you have a handle on this. That was a one-stage transformation, but I think we need to take this up and challenge your minds a bit. And we're going to do a 2-stage. And we're going to do this through something really cool that we've had at Roper Mountain for a while, but this is the first chance we've had to use it in a program. We bought this for something that we wound up not using it for, so it sat in storage until we had a great opportunity to use it with you today. So I'm going to set this up. This is a desk lamp. This is not the cool thing that we had in storage. All right? So I'm going to put this here. And then I have, here's the thing that I wanted to show you. So excited. All right? This is called a water lily. This water lily has a fan-looking thing on it. And it moves if something moves it or passes through it. And water lily, we're going to pass water through it. And as the water moves through, that fan's going to move and something's going to happen. Now I have my last ingredient here. A bucket of water. It's blue water, but it's just food coloring. So no streaks here. All right, and what we're going to do is we're going to pour the water in. It's going to make the fan move. Something's going to happen, and we're going to watch the desk lamp to see what happens. So we're going to get the lights. All right, so aim it the best we can. Just watch it. We do have some lights on in the room so you can see what's happening in here, but you will see the desk lamp do something. So I'm going to pour it in. And you see the light is turning on. And as the fan slows down, it turns off. So I will show that to you again. So I'm going to hold up the water lily, and I will spin the fan about the rate it was going with the water. And you see that light turns on, and then as it slows down, it turns off. And I'll do it one more time. And so that is a transformation of energy. So we had two stages again. So we started with the energy of me pouring the water moving through and moving the fan, something happening inside of the water lily, and then the transformation inside the lamp. So let's see if we can figure this out. Think in your mind. We'll start at the end. What do you think was the energy that came out of the system here? All right, I think you're thinking radiant energy because we said we're going to interchange those today. Awesome. And now we're going to come back to the beginning. What energy did we put into the system as the water moved, the fan moved? And you're probably thinking movement energy, mechanical energy. So that kinetic movement energy. All right? And then somehow, some way, this was transformed into an energy that allowed a electric light to turn on. So electric light must be electrical energy. So when the water moved through and moved the fan, that movement energy in some way was transformed into electric energy that then the lamp could use to transform the energy into radiant. And that's because this is a generator. A generator is a device that transforms mechanical into electrical energy, and it does it by using magnets moving past a wire. There's magnets attached to the yellow part of this, copper wire on the inside of the frame here, and a copper wire has electrons that move easily, and electrons are attracted to magnets. If you move a magnet past copper wire in a circuit, you get electrical energy because you move electrons, and that's how generators work. And that is what's happening. We turned on the light. And that brings us to what we started with today. And that is the plasmosphere. I think you have now put together enough information to be able to be that smartest person in the room, like we said. All right. So the plasmosphere, we'll turn it on. We will turn it on. Did I unplug it? Let me see what happened here. So the plasmosphere does not seem to be working. There we go. Sorry about that. All right, it's working now. All right, awesome. So we have the plasmosphere. What's happening inside the plasmosphere is this. We're getting electrical energy from the wall, and we can change views for this. All right. So we're getting electrical energy from the wall. Oh, let's change back to the other view. Sorry about that. When we unplugged this, we turned off the camera by accident, so we have to let it warm up. All right, so we'll just show you this way. It's fine. All right, so here we go. We're getting electrical energy from the wall. Inside of the plasmosphere is a tiny Tesla coil. So Tesla like the car, coil like a coil of wire. Don't have a lot of time to tell you about what those are, but it's a really cool thing to look at. Nikola Tesla invented them a long, long time ago. But inside of here is that Tesla coil, and Tesla coil sends out electrical energy after amplifying it. And it's going out looking for the ground, trying to complete a circuit to the ground. And as it does it, it passes through gas. We have some gas inside of here that reacts to the electrical energy, and it heats up because of the electrical energy. And when I put my hand here, what happens is, and we should be able to change views now. I think the camera is ready. There we go. So you can see as the electrical energy finds a path to the ground, and it's using me, by the way. The electrical energy is moving over my skin, and this is safe, I promise. It moves over my skin to the ground, and our skin can take low amounts of energy. It happens more than we know. You don't want to test with high amounts of energy, but low amounts of energy, it happens all the time. So it's moving over my skin after it passes through the glass to the ground, and I'm a conductor right now. And it's allowing the electrons to all gather in one place and heat up the gas. And that superheated gas is called plasma. It's the fourth state of matter. And that plasma, one of its properties is to transform thermal energy into light. And all of you have seen an example of that with lightning. That's what's happening with lightning. Electrical energy is causing thermal energy, which is causing radiant as plasma is produced. All right, so we have the state of matter plasma causing that. And then because I am the circuit right now, I can plug a light into the circuit just like we do plugging a light into a lamp into the wall. And that's why this lights up. The electricity moves through the light. It excites the gas inside. It's not plasma this time, and it's not a chemical reaction. It is just an excited state for this gas, and this gas glows. It fluoresces when it does, and that's fluorescent light. So that's why this is happening, and it's going over my skin to the ground. When I hold it here, it can still go through the air to get to the light over my skin to the ground. And then when I do this, and it doesn't light the whole thing up, but just near my hand, what's happening is it's looking for the ground. It finds that the ground's not there, and it comes back. All right, and then that's what's going on there. So the next time you see one of these, you can tell people about the Tesla coil inside and the plasma and the gas, and it's all really cool. And that's it. I feel like y'all were really tracking with me as we went, and we're so glad that you were able to join us this way. Can't wait for you to be here in person. But until that time, we'll continue to provide these opportunities for you to learn from us virtually. And so thanks for joining us, and we'll see you next time. Bye.